Hi everybody, welcome back to the Feynman technique. Today we're going to be evaluating this integral that I got off the channel Michael Penn. I've been doing a lot of integrals that I got off of his channel lately. We're going to use the alternating sum of the reciprocals of the squares to solve it. And we're also going to be using another identity that I'm going to derive right now. All right, so we'll start with negative pi squared over 12 being equal to this thing. But we're going to write this as three separate sums. Those sums are going to be this. The first sum is going to be the sum as n equals 1 to infinity of negative 1 to the n over 3n all squared, plus the sum as n goes from 1 to infinity of, that's negative 1 to the 3n. Negative 1 to the 3n minus 1 over 3n minus 1 all squared, plus the sum as n goes from 1 to infinity of negative 1 to the n, 3n minus 2 over 3n minus 2 all squared. And really quick, I'll just kind of briefly explain why this is equal to this. So in this sum, we would basically, if we plugged in n equals 1, we would get the third term of this, because we would have negative 1 to the third power over 9 squared, which is exactly the third term in this series. If we plugged in 2, we would get the sixth term of this series. Likewise for here, in this sum, if we plugged in 1, we would get the second. If we plugged in 2, we would get the fifth. If we plugged in 3, we would get the eighth. And in this one, if we plug in 1, we get the first term. If we plug in 2, we get the fourth term, seventh term, 10th term, and so on and so on. Okay. And so now let's start manipulating these sums individually. Well, negative 1 to the 3n is the same as negative 1 cubed to the n. So that's just negative 1 to the n, because negative 1 cubed is negative 1. And then we can also factor out a 1 over 9. Giving us just n squared. All right, well, let's notice that this is exactly the alternating sum of the reciprocals of the squares. So this is just 1/9 times negative pi squared over 12. In other words, this term right here, this is equal to negative pi squared over 9 times 12. All right, let's manipulate this one a little bit. We can split this numerator up into negative 1 to the 3n times negative 1 to the negative 1. In other words, we could just get rid of that negative 1 on the exponent and switch this to a negative sign. And again, we can just get rid of this 3 right here, because negative 1 to the 3n is the same as negative 1 to the n. Okay. And right here, we can split off this negative 1 to the negative 2, which is just 1. In other words, we can just get rid of that negative 2. And again, we can erase that 3. All right. So now, what we've just shown is what I wanted to show. Let's see. We're just going to take this on the left-hand side, but I'll write it like this. I'm going to take this term minus this term. That would be the sum as n goes from 1 to infinity of negative 1 to the n over 3n minus 2 all squared, minus the sum as n equals 1 to infinity of negative 1 to the n over 3n minus 1 squared. And that's going to be equal to, well, let's see, negative pi squared over 12 plus pi squared over 9 times 12. In other words, that is going to be equal to negative 2 pi squared over 27. And verify that for yourself if you'd like. You bring this to the other side and it becomes pi squared over 9 times 12 minus 9 pi squared over 9 times 12, or negative 8 pi squared over 9 times 12. Dividing the top and the bottom by 4 would give you negative 2 pi squared over 9 times 3, or negative 2 pi squared over 27. So that is the second identity that we will be using. All right, so now let's actually get started on solving the integral. All right, we're going to use a familiar trick to start. We're going to break it up into two separate integrals. The first one going from 0 to 1, so that's 0 to 1 natural log x over x cubed plus 1 dx, plus the integral from 1 to infinity of natural log x over x cubed plus 1 dx. All right, we're going to take x to 1 over x on this second one. So this will become a 0. This will become a 1. I don't even know why I erased it. All right, this will become a natural log 1 over x, which is just natural log, or negative natural log x. All right, this is going to become an x to the negative 3, and we'll recover a negative 1 over x squared also. There's going to be a dx there after I'm done. All right, we'll distribute this x squared. This will become x to the negative 1 plus x squared. We'll distribute the negative sign. Well, we'll use this negative sign to switch the bounds of integration. All right, so we already distributed that. So this is just dx. And then we'll multiply the top and the bottom by x. So x, this would become a 1, and this would become an x cubed. All right. So if I is equal to this, then it's also equal to this. All right. Now let's go ahead and create a function of t. All right, our function of t is going to be equal to the integral from 0 to 1 of x to the t over x cubed plus 1 dx. And that's going to be equal to, well, let's see, that would be the integral from 0 to 1 of x to the t times the sum as n goes from 0 to infinity of negative 1 to the n times x to the 3n dx. We can bring this x to the t inside as a x to the 3n plus t. Then we can switch our summation and integration notations. So we'd have, this will be the integral going from 0 to 1, and then we'd have the sum from n equals 0 to infinity. We can bring this negative 1 to the n inside. Evaluating this integral would give you 1 over 3n plus t plus 1. So that's going to be it. We would just get negative 1 to the n over 3n plus t plus 1. All right. I hope you followed along with that. Rewind the video if you didn't. But I've done that same process many times on the channel before. Okay. So what now? Well, let's take f prime of t. All right. So that means f prime of t is going to be equal to the integral from 0 to 1 of x to the t times natural log x over x x cubed plus 1 dx. And it's also going to be equal to the sum as n goes from 0 to infinity of negative 1 to the n. And this is a 1 over 3n plus t plus 1. In other words, 3n plus t plus 1 to the negative 1. So that's going to give us a negative 3n plus t plus 1 to the negative 2. 3n plus t plus 1 to the negative 2. All right. Well, let's see. If we took f prime and evaluated at the point 0, we'd get this part of our integral. And if we took f prime and evaluated it at 1, we would get this part of our integral. So, in other words, we can say that I is going to be equal to f prime evaluated at 0 minus f prime evaluated at 1. Okay. So let's do it. That means I is equal to, let's see, f prime evaluated at 0. This is our f prime right here. So we'd get negative sum going from n equals 0 to infinity of negative 1 to the n over 3n plus 0 plus 1, 3n plus 1, all squared, plus the sum as n goes from 0, right, it's a plus, right, because we have a minus times a minus, so that's plus. So n equals 0 to infinity of negative 1 to the n over, let's see, we'd get, plugging 1 in for our t would give us 3n plus t, 3n plus 2, all squared. 3n plus 2, all squared. Okay. All right, what now? Well, we almost have this, except we have a plus 2 and a plus 1 instead of a minus 2 and a minus 1, and our n starts at 1. So first, let's go ahead and take care of the fact that our n is starting at 0 here. So we'll use a familiar trick. We're going to advance n by 1, and then subtract 1 from all our n values inside the sum. So if we subtracted 1 from this n value, it would just switch the sign of the entire thing. Okay, if we subtracted 1 from this n, we'd get 3n minus 3, and then plus 1 would just be a 3n minus 2. Minus 2. Okay, let's do the same thing here. We'll advance n by 1. That would become an n minus 1, but that would just switch our sign. This would become a 3n minus 3 plus 2, or just a 3n minus 1. Okay. Well, that's it. That is exactly this identity that I proved. Therefore, right, it is, right? We have n going from 1 to infinity, negative 1 to the n, over 3n minus 2 all squared, minus the sum going from n equals 1 to infinity of negative 1 to the n over 3n minus 1 all squared. And that's equal to negative 2 pi squared over 27. So negative 2 pi squared over 27 is the answer. Hope you enjoyed that.